Okay, so we live. Hello. Hello and welcome. Good evening. I wanted to return to solving a problem. Have to forgive me, I don't know, I'm not I don't know what the word is, somewhat hesitant to kind of get back into this. But yeah, I just wanted to take a look at this problem we were looking at the other day. I kind of pondered it for a while. Kind of took a break. Yeah, there were a lot of things that I needed to address and look at, and also this problem seemed to be really hard for some reason for me. I felt like I was kind of struggling with it, but this is kind of an easy question. But yeah, so let me read the problem quickly. I think we could solve it relatively quickly. We'll give it a shot. Given a robot column screen and a sentence represented as a list of strings, return the number of times the given sentence can be fitted on the screen. Order of words in the sentence must remain unchanged, and a word cannot be split into two lines. A single space must separate two consecutive words in a line. So sentence, hello world, 2 rows, 8 columns. Hello world, one time you could write it. If you have A, B, C, D, and E, 3 rows and 6 columns, you'd have A, B, C, D, and then E, and then A, B, C, D, E character signifies an empty space on the screen, this dash. And finally, I had apple pie on 4 rows and 5 columns. 1, 2, 3, 4 rows, 1, 2, 3, 4, 5 columns. I had apple pie, and you would only get one sentence. So the solution that I thought of, and the sentences are not, you only have about 100 words, I think, in each sentence, and the size of each word is only at most 10 characters. So about 1,000 each sentence. And it's all lowercase English letters, and you've got the number of rows and columns is going to be bounded by about 20,000. Yeah, 10 to the third is 1,000, so 10 to the fourth is 20,000. So rows and columns bounded by 20,000. So now, what's interesting about this question, I think the solution is going to be something like the following. Basically, if the row is larger than the total size number of characters, the total size of your sentence with the spaces, right? So you can figure out how many characters you need for the whole sentence with spaces. Basically, you can figure out how many, given a certain amount of row, how many sentences you can fit, and then you can figure out from there what's left over, right? And now you're in the situation where now you want to fit as many words as you can in that space. And you can write an algorithm, I believe, that would be linear in the number of rows, which again we said is bounded by 20,000, so it'd be pretty efficient, pretty quick. There's, I think, going to be one pre-processing step where, obviously, you sort of shrink each row down to less than one sentence, if that makes sense, if they're not already there. And then from there you can say, okay, given how much space we have left on the row, we could figure out how deep into the next sentence we could possibly go, right? And then on the next row, that's where you would start for the next sentence. And that's kind of the idea. It gets a little hairy though, and that's kind of why I've been kind of avoiding this question, I guess. There's a couple questions that I've been avoiding, but this one also, because it's a little bit not so obvious what to do. I think, yeah, pre-processing step we can do to figure out, given a certain number of characters, which which word are we splitting on, right? That can be done in a pre-processing step. So we can kind of have like, because there's only 1,000 only 1,000 characters per word. Excuse me, 1,000 characters per sentence, and then we can just say at each character which word would be like the next word, or I'm not sure exactly what the query would want to have. Probably it would be like, it would be, I guess, the index of one of the words, and would it be, I want to say something like what the index of the word that would follow on the next line, right? In other words, the word that would quote unquote be cut off, more or less cut off. I think you'd want to do it that way. You'd want to keep that kind of, what question are we answering, I guess, with that pre-processing step. That's kind of what we'd want to do. And then so the deal with that is, with that pre-processing step, so if the rows are actually smaller than the total size of the word, or excuse me, total size of the sentence, with also including the spaces, then the thing about that's interesting is you're in this kind of a situation, right, where you have hello and then world is split onto two pieces. The deal with that is, so let's suppose for a moment that every row is smaller than a word. Then we would find, we'd find the point where the next word is going to be in the sentence, and so like in this case, right, world would be that index in the next spot, and then from there, if the rest of the row actually exceeds the number of characters we need to place the rest of the sentence, which we can tell from the index, I guess we would also want to have a mapping of so it would be number of characters left in the row, knowing that this is smaller than the sort of the total sentence, and that would map to which word would appear next on the next row, and also the word that appears in the next row, you'd want to map that to how many characters are left in the sentence. All right, so you can actually do two sort of pre-processing steps. By the way, these things you could also do, like, don't necessarily need to do them because it's only 1,000 characters altogether in the worst case. You don't necessarily need to pre-process these queries. Like, these queries could probably be done just in a brute force approach, both of them, but it's probably better to pre-process them. So then so then you can actually figure out, if this particular word at this index, basically the question would be, if this word at this particular index is the start of the sentence, how many characters would we need to complete the sentence? And if that's the case, then you would complete the sentence and start a new sentence and sort of do the same thing again, if you have enough characters from that point. And I think that's it. I think it's relatively simple. You just do row by row kind of a deal, and then you kind of scroll. If the rows are very large, or rather you have a very large number of columns, and the rows are very long, then that kind of, basically a division is only one division to kind of scroll all the way to the end until you're at that point where excuse me, you don't have enough characters to complete a sentence. And then you can, with those characters left over, you can figure out how deep into the next sentence you would go. That's kind of it. Like, it's actually not a very hard question, I guess. I think for me, it was just really hard for me to kind of think about. I don't really know why. I guess for whatever reason, maybe I just need more practice. I don't know. But I kind of struggled with this one. So, see if I could articulate the solution, or try to. My thinking is we'd want to go row by row, and you'd want to, at each row, place as many sentences as you need, right? With using a division, right? Knowing how many characters you would need, how many columns you'd use up to place all of the sentences until you can't place a full sentence. Then with the amount of characters that you have available, the number of columns left, you can determine using, I guess, a query, how deep into the sentence you would be if you try to fit as many words as you could, and which word you'd start the next row with, right? And then you would go ahead and start the next row with that word, and then you would want to ask the question: is there enough? Is the row large enough or long enough to fit the rest of the sentence from where we're starting now there? If it is, then you would repeat the same thing you just did, but with subtracting those characters, right? If not, then it's still similar to what you just did, but now you would jump further again into how deep into the sentence you can go to figure out what the next word would be in the next line. And obviously, once you've completed a sentence, then you would add 1 to your total count. If you scrolled forward, right, the rows are large enough to fully contain a sentence, then you would add 1 as whatever that division is. You'd add all of those as well to the count. And you do that until you get through all the rows, and that's it. It's like super simple kind of thing. Yeah, I think you could even just have like a pointer, like a double, not double pointer, but a pointer that sort of keeps track of 2 different indices. One that's like which character in a particular word that you're pointing to. That's sort of the next character to write. And like you could actually just write all the characters directly into the. I think the only reason why you don't want to do it that way is because I think it'd be a little too inefficient to kind of literally write all of the characters in kind of an abstracted sort of row by column structure. The only issue with that is that it's a little too big to do that. I guess maybe you could skip. You could do the writing, quote unquote, kind of idea, but the issue with that is like you do have to do the skipping part also, where if the row is very large and each row could contain many sentences, then you'd want to write all the sentences. You would want to sort of skip that part and jump right to the important part, which is like how many characters you have left to work with in that row. So yeah, something like that. I'm wondering if I want to write like how this would look without doing a pre-processing step first. I don't actually know. So this is a pretty interesting question. I like this question. This definitely give us a thumbs up before, because I kind of got stumped on it, and then I also I came back to it a few times thinking about it, and then like I'm looking at it again now, and I'm like, man, this question really got me. You know, like this would be like a really hard question for me, even after seeing it already once before and sort of knowing the answer. Like it would be kind of difficult for me. Like I think just coding it and thinking about it, it's a little challenging. But I do want to perform this pre-processing step where we can go from pre-process an array such that we can answer. We can know that given a number of characters left in a row. Oh, I should do this wrong. Available, or yeah, remaining in a row, we can determine how many. We determine which. Yeah, I guess how many words in the remaining in a sentence given a number of characters remaining in a row, we can determine how many words. Determine which. It's confusing, right? It's like I don't know, man. I'm like not even expressing it properly. Given a number of characters remaining in a row, can determine and a starting point and a starting word. We'll place starting word place initially, or a starting word in the sentence, not necessarily the beginning. Beginning of the sentence. Given a number of characters remaining in a row, we can quickly determine which word start the next row. Yeah, quite a confusing thing. I don't know, I'm not expressing that particularly well or rigorously, but so we want the number of remaining characters. So it's going to be something like array size. We want 4 so you add the number of characters each time, and then we also want to add 1. And then subtract 1 at the end. That's basically counting all the characters in the sentence, as well as accumulating all the characters in the sentence, as well as the spaces between each word, right? Each word has to have a space between them, except the last word. The last word doesn't need to have a space. And then you would say, so we're going to say standard vector of integers, and we're going to say position to word, I guess. Yeah. I don't really know. I don't know what to call this thing, but it's in sort of int to int kind of mapping. And it's going to be initially 0 for everything. The initial value is 0. Now I don't recall if this goes number to default value. I think it goes number to default value, so it's array size. Right, we can just check that quickly. That we could do quickly. Also, I might have to go too. I promised a friend that I was going to assist him later today. Yeah. Hold on, somewhere we have. I think the second one is a count, right? No. Count value. It goes count then value. Yeah, no, I had that right. That's what I thought. Yeah, no, we're good. That's what I thought. Count then value. Right. We'll just initialize it 0. And we would say, now we would say 4 do sort of a while loop, I guess. I don't know about this, man. This is kind of, yeah, okay. This is going to get a little bit confusing. So each word we're going to say for loop. Just wondering if there's a better way to do this. I want to say it doesn't really matter if we do it this way. I think that's fine. So I equals 0, I is less than dot size plus I. We're going to say array, I don't know, position to word of position is going to be equal to, oh no, we do want a word count. Which word? So the next word, and also the position, we're going to add increment the position here. And then we actually set it one more time here. So there's this extra space that you have also. That extra space, that's actually going to point to the next word. Yeah. Yeah, just a little confusing here, but you just have to check here. So if position is less than array size, I don't know how to really express that in a way that's really like clean. Position to word of position is then going to be equal to which word? The next one. Now this is just to not go off the edge at the last word that you place. This position will be sort of off the edge, and that should do that. That should do it for the pre-processing for that. The idea would be, so we're going to look through each row. And we're going to say so if we also want to do the other way around too. Pre-process an array such that given the number, given a starting word in the sentence, we can easily determine number of characters, columns required in a new row complete sentence. So we have the starting word So basically the first word is going to be that full array size. The second word is going to be, you subtract the first number of characters in the first word, first sentence, and you also don't need the spacing character, right? If you're starting for the first, so you could, yeah. So I think you could do that for each sentence. So we would say something like, for int I equals 0, I is less than sentence dot size, increment I. You would say initially total, it's going to be this array size, total required, we'll say. We're going to say standard vector int word to required, just do it that way. And it's going to be sentence size, same size, the number, right, the number of words. Initialize as 0. So initially, it's going to be equal to required. All right, the first word is going to be the whole sentence, the whole sentence, and then required we're going to decrement by sentence of I dot size. All right, so we added, so we don't need the first word, or we don't need that word that we just processed. And we also don't need the spacing character. And once we get all the way to the end, to the last word in the sentence, so world, for instance, we would subtract required, but we wouldn't place anything. So I equals 0 would give you hello plus world, which is 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. I think it's 10. That would give you 11 for the first one, and the second one would give you 5. Right? You subtract 6, and then you wouldn't go past that. So I think that's fine. Okay, good. Yeah, it's a little confusing there. These two pre-processing steps, but this word to required and this position to word. I think we're going to use these two structures to kind of quickly answer these queries. And again, it's taken me kind of a while to kind of go through this, so not forgive me, but like, yeah, it's taken me some time to do this, I guess. So now we have for each row, we want to do this processing where if the remaining columns, so which is the total, sort of the total, we do columns is less than, okay, so determine number of characters required to complete, and we're going to say int count, we're going to say next starting word, or starting word starts off at 0, complete a sentence given a beginning word. So I would just say int required. It's going to be word to required of starting word. If the number of columns is less than required, cannot complete a full sentence. Otherwise, if the number of columns is greater than or equal to required, and then we can try to complete a sentence. So can I complete a full sentence? Update the starting word and continue. So what we would say is this is maybe like really confusing. I think there's probably a better way to do this. There's definitely a better way to do this. I should probably look at the discussion and see like how people did this in a way that's concise, because it's kind of hard to kind of get this in a way it's like you could do it in a clean, simple way and code it quickly. Because now the problem here is that if we don't have enough, let's say, then we want to scroll forward even more words. But part of that issue is that we don't know where in this array should we be. We kind of want to go back the other way too. That's kind of confusing. Because we'd want to know, like we have a starting word, but we don't necessarily know how many characters that starting word, how deep that is. And basically we want to take how deep we are and go deeper, right, in this position. Which means we might actually need more information even still. Well, we can keep track of that. There's a starting word, and there's also yeah, how deep is each word into the word to required. So many characters are required, but how many characters are we deep into the sentence at that point, though? I want to say just subtract, right? If you just subtract this word to required, that's how deep you are, right? So if we're on 1, required is 5 characters, so 11 minus 5 would be 11 for the whole thing. 11 minus 5 means we're at, which character are we at? We're at 7th character. Minus 5 plus 1. 11 minus 5 plus 1. Yeah, I think so. I think that's fine. I think we don't actually need to know that. Yes, the current position is going to be the array size minus required plus 1. And then, so current word is then position to word of the current position. And then we update our starting word. This current word. There we go. That's what we want. Right. Otherwise, right, so now we have at least enough columns for what's required. We want to say update our columns or sort of leftover or current amount, current column or characters. We're going to say it's columns minus required. Increment our count. Complete the sentence. Determine the next word depending on how many characters are left over. And this is the part that, this is like the optimization that makes it way more efficient. So in place as many sentences in the remaining characters in the row that will fit. So we'll say int placed is going to be current characters divided by array size, and count plus equals placed. And then current characters is going to be updated to the number of it's going to be the number of place sentences times those sentences. Now what's tricky about this is actually placing each sentence. You need to add another, you have to actually add a space between each sentence too, which makes things even more confusing. So we can have a space on the left side, I think that makes sense. If we can do, so now we've completed a sentence. We're going to put the space on the left side and add a character, and then we'll have a certain number of characters left over after we place everything. Yeah, this actually should work fine. I think it's array size plus 1. Note, we add a 1, total sentence size, considering previously placed word. Yeah, a little confusing, but I think that's the right way to do it. Now we place all these sentences. Now we kind of repeat the same thing here, which is the starting word here is 0, and we would say determine remaining characters. Determine the next starting word. So this next starting word, or we'll say again, yeah, space on the left, or yeah, for another first space. If there are any more characters. If there aren't, then we set the starting word to 0. Otherwise, if there are more characters, then we would say starting word is going to be equal to this position to word of however many characters we have left. And this is wrong. Yeah, this is wrong. Array size minus required plus 1 gives you the current position in the array, and then our current word there's right, using the starting word, we can figure out how far we're in. But now we have this new set of columns, right? Less than what's required. We need to actually change the starting word. This will actually just give us the same starting word over and over again. So we need to add to this position to word, increment the position based on number of characters available. New position is equal to current position plus the columns. Determine the new starting word. Yeah, new position is what we want. Okay, a little confusing. Right, and we said that we don't have enough characters, so we're definitely going to use this to complete the word, the sentence rather. Now, if we do have enough to complete the sentence, then we do go ahead and do that. Increment the count, place a whole bunch of other sentences, increment again. Yeah, one more character for a space. Now, like let's say, now this might be kind of tricky here. Let's say we placed a sentence, then we do have to subtract a character for the next words. If we didn't place a sentence, we still have to subtract a character. So, okay, doesn't matter either case, because this we placed a sentence. So, remaining characters determine the next starting word. So, right, this is simple. Just how deep into the sentence are we going to go? What's the next starting word? And if we've used all the characters possible, then we just start off at 0. I think that's it. I think that's all we got to do. And then at the end of all of this, return our count. Now this is pretty funky. Don't know if it's, oh, okay. Worked in that case. Let's try some other cases. Really need to try a bunch of cases, I think, for this. I wasn't even expecting it to compile, much less be correct. Okay, there we go. Much less be compile or have runtime errors or be correct, right? So we ran into an issue with the second test case. Okay, let's see. Just to make sure we're in the right spot. Yeah, I kind of would expect some runtime errors. I kind of don't think this is going to run properly initially because it's just too confusing trying to word all of this, express all of this. See if we could find out where we run into our runtime error. I wasn't expecting a runtime error. It's got to be some kind of an array access or something. Oh no, I gotta go. Alright, we'll do like 10 minutes of debugging. If I can't get it right, then I'll probably delete this VOD and come back to it later. Yeah, man. Challenging question. Challenging question. Definitely a pretty good interview question because it kind of forces the interviewee to really think and kind of manipulate the question, try to come up with something that's cogent. Like, this is not a very cogent or concise answer that I've got here. Solution makes it a lot more challenging to code, to program as well. All right, let's see if we can find a spot that's where this runtime error is happening. All right, now the pre-processing step. about this part here. You can't really do this kind of debugging in a whiteboard interview either as well, which is kind of unfortunate. Really, so it looks like this happened once. Position to word. Now, it's strictly less than the number of required amount, so this can't go over the edge. Yeah, there's probably some kind of off by one thing going on here. Okay, so you have A, B, C, D. So hello 1 happens. Now, do we get through this whole block? No. All right. That's what happens. Current position is array size minus required plus 1. Required is word to required starting word. Starting word is 0. Word to required at this point would be the whole array size, right? So required is the whole array size. Columns less than the required, of course. The whole sentence, we know that. Position is the array size minus required plus 1, so current position is 1. So I think this is wrong, right? This 1 we don't necessarily need, right? That's if it's you add 1 if oh, I see. That's interesting. Just say if. That's kind of funky. That's a little awkward. How do you even explain this? Wrong though. Output 0, expected 2. Okay, a little bit better. Now we're not crashing. I wonder if this is even the truth. I don't actually know. That was almost 5 minutes messing around with that, huh? That might be wrong, this idea here. Okay, so we get A, B, C, D. We should see E here. So let's just print the starting word in each step, each row. I think I don't have the right answer here. I think I'm gonna run into too many issues with this. The code is too funky. So starting word is 0. It doesn't get updated here, which it should. So we get this current position, new position, current position plus the number of columns. And then our current word is then position a word, new position. Starting word is 0, new position, new word, new position is 6, so 0, 1, 2, 3, 4, 5, 6? Okay, interesting. Position a word of new position, just 6. Current word, starting word should be 0, 1, 2, should be 2. New word is 0. Okay, that's not right. What's position to word look like? Okay. Okay, what do we get here? Position to word 0, 1, 2, 3, 4, 5, 6. 6 goes back to 0. Oh. No kidding. What? How did that happen? Where did that happen? Where did that happen? What? What is going on? How big is this array? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. On 7 it should be 3. Which word? Increment the position. Increment the word. And if position is less than array size, set position of word to be which word? Why so confused? So confused. So my pre-processing step is wrong. Oh man, I gotta get going soon. We can do maybe another 5 minutes. 0 word size, that's fine. Increment the position. The position increases 0. So it starts off at 0, which is correct, right? A is 0. The next one we add, increment the word. This position is still less than the array size, right? Set that to which word, which is 1. Then we have BCD. I'm so confused. There's 3 of them. It should be 1, 2, 3. So I think that's part of the problem. There should be actually, you write the first position and then there's a space that should go to the next spot, which is kind of here. Hold on, let me give it another 5 minutes. Yeah, that's what I'm saying, man. Like, I would just get, if this was an interview question I was trying to do quickly, I would get destroyed. The next space should go to the next word. So which word, next space, should go here. And then you have another 3 characters which go to whatever word you're currently pointing to. BCD, right? So it should be 1, 2, 3. Now, that's a little bit strange. I think part of the issue is add a space. Space should point to the next word. Alright, I think this is why. Now what can happen here, and I think it's going to happen, is, yeah, we get a runtime error now. Because this extra space that we add points to the upcoming word. Now we get 1, 2, 3. Now we would get 1, 2, 3 for BCD. But I think this is going to give us sort of too many spaces, right? Because now we're going to have, there's a space for E. Yeah, there's going to be a space at the end here. We just say if position is less than array size. Yeah, I think that's what we need to do. A little confusing. Something like this. Yeah, there we go. Okay, now it goes 0, 1, 2, 3, 4 should be for BCD, and then 3. It's 2 is 3, right? 0, 1, and 2 for E. Okay, but now we're still wrong on our answer. Why is that though? Okay, at least we fixed this. I thought that might happen. I thought something like that was going to happen. I don't know. It seems like it's such an unusual kind of a structure. I think it's probably some other issue too. It's probably an issue with the other structure as well. So position a word. We have word to required. It's probably incorrect also. Okay. What does this look like? 751. So the first word you need 1, 2, 3, 4, 5, 6, 7 characters. The second word you need 1, 2, 3, 4, 5 characters, and the last word you need 1 character. Okay, that's actually correct. Nice. Okay. So starting word is 0. And then we have a new position, and the new word is 2, right? And right, okay. So we're going to start out in E, okay. Then the next routine, we say, just running this again. The next routine we should start at 1, I think. Columns less than required. So hello 1, now hello 2. Starting word is 0, which is wrong. It should start at 1, not 0. But we do complete the sentence. Current characters, columns minus required. Increment the count. What's required to complete this is just 1 character. So now we have, this is 1, 2, 3, 4, 5 characters, I think. 5 characters. Can't fit any more sentences. Decrement by 1 and determine the next starting word. Current characters is greater than 0, which it is. Right, should be 4. Starting word, position to word, current characters. So there's 4. Which word do we start at? Now we said 4, 0, 1, 2, 3, 4. Should be 1. You actually, this is somewhat wrong. Oh yeah, no, it's 1 less character. We have 1, 2, 3, 4. 4 characters. 1, 0, 1, 2, 3, 4. It's actually, I think you subtract 1 on the number of characters, but I think you'll still get 0, 1, 2, 3, 4. Starting word shouldn't be 0. How do we get? Remaining characters. I gotta go. Oh, -1. Well, there you go. That makes a lot of sense. Why is it 0? Excuse me. Five remaining characters, which makes sense. Then that should go to, oh, whoa. Place is 0. Count increment by 0. Oh, I see. It actually should be minus equals. It's a good thing we ran through this. There we go. Okay, I was wondering. It's like there's something's not quite right here. Just a few errors. Took a while to fix them. So we had an issue with how we had set up our one of our pre-processing steps, and also we had an issue with how we our logic. I was supposed to do a subtraction there, but I misprogrammed that and made it that not a subtraction, but the other not a subtraction, but a direct replacement, I guess. Okay, so this is looking promising. Not necessarily correct, but looks like it might be. We definitely want to do more test cases, though. I don't know if I can think of some random things here. Let's do A and 5, 5. Let's try that. See what we get. Let's try a bunch of different things. Let's do like A, B, or A, B, 5, 2. Let's try A, B, B, C, 120. Some random inputs, I guess. I gotta get going. I don't know. Something like this. Let's see what we get if we do these. I gotta go. I'm so afraid to submit this. I haven't run enough test cases. Oh, it's correct on these. Alright, let's go for it. It's almost certainly wrong. Hey, it's right. Got it. And we're almost faster than everybody else. Sweet. Almost. Let's see if we can get it 100%. Nope. We're very close. Oh. Slower now. We're so close. Hey, 100%. All right. Faster than everybody else. Sweet. All right. Awesome. So that took a while. How long did it take? It took an hour. It took an hour kind of already knowing the answer too. Well, thank you all for watching. Appreciate it. I will talk to you soon. Have a good rest of your day. And yeah, that was kind of brutal. That was kind of brutal. I would say. I mean, that's the answer. It's one way of doing it. It's about as efficient as you can, right? 100% of all the solutions, faster than everybody's solution. Well, I don't know. All right. Well, thank you for watching. Take care. Talk to you soon.